everyone. As we continue to learn about living organisms and life sciences, today we're going to focus on the honeybee. The honeybee is an insect with 6 legs, 2 antennae, it has wings, and one of the structures that we know about the honeybee is its stinger, a structure that most of us really don't like. But just a little fun fact I wanted to share with you. Did you know that not all bees have stingers? Actually, it's only the females that have a stinger. The male don't have a stinger. Now the female stinger, you might know that they die after they sting a human. And that's true, that's a fact. Their stingers are barbed, meaning they have a little hook at the end, something like this, maybe like a little paper clip. So when the stinger goes in, if it tries to pull it out, it gets stuck in there. And the stinger is connected to all of the insides and the intestines of the bee. So when the stinger goes in, all of the insides also leave the bee's body, causing the bee to die. Now, why would a bee want to sting us if they know they're going to die? Well, in fact, they don't. Their stingers are not meant to sting humans. Their stingers are meant to sting other insects and other predators that they may have. We're not their predator, but they do sting us because they get nervous, they're not sure what to do, and they end up dying. But in fact, they can use their stinger on other insects many, many times without ever having any bad effect on the bee. Now, another thing we know the bee is really famous for is flying around from flower to flower, drinking nectar, collecting pollen, and making honey. Now this honey is used for the bees as well. They take the honey, they make the honey back in their beehive, and they eat it, but we also love their honey. As they're making the honey, they also have to make little compartments for their homes, and those compartments are called cells. Each bee lives in its own cell, and it also uses the cells to store the honey. Now these cells are made out of wax. What we're going to do today is an engineering activity that shows us how do bees know what shape to make these cells. And do they all make the same shape? Do they make different shapes? How does it all really work? For today's lab, you're going to need one last set of materials from your enrichment bag. These are the paper strips that have been cut into these regular shapes. For this lab, you will need one piece of paper, 8.5 by 11. Mine is colored just to show contrast. It does not need to be colored. You will need your strips of cardboard. You will need tape, and you will need about 25 paper clips. What we're going to do is, the honeybee has many different options as to what shape to make its cells. The shapes could be a circle, a triangle, a square, or even more complicated shapes. It could be a pentagon, a hexagon, a heptagon, an octagon. Now, we're going to test out 2 different shapes and see which one is better for maximizing the most amount of honey. Which shape is the most efficient? Which shape takes up the least amount of space but holds the most amount of honey? What we're going to focus on today are circles and hexagons. We're going to use these cardboard sheets to make circles or hexagons and see which shape gives us the most number of circles or hexagons. Which one can we fit the most of? Let me show you how to do this. Now it's important to point out A circle has no sides, and a hexagon has 1, 2, 3, 4, 5, 6 sides. Before we get started, on your sheets, go ahead and make a prediction as to which shape you think will hold the most amount of honey and which shape will allow for the most number of cells onto this one sheet that we have here. Now that you have made your prediction, let me show you how to make a circle and a hexagon. The circles are going to be easier. You're going to hold your strip and you're going to connect them edge to edge, but not like this. You're going to have them overlap just slightly, and then have your tape ready and tape the two ends together. And now we have created a circle. Let's try that one more time. We have our circle. Now remember again, I'm not connecting the edges, I'm overlapping them just slightly. And then I'm going to have my tape. And now I have created a circle. Now to go ahead and make the hexagon, you're going to have to start with a circle. So once you've made your circle, then you're going to flatten the circle out, making sure not to do it at this crease over here. Make two other flat edges. And using your hands, you want to flatten them out really well and smooth them out. Then you're going to fold one side about 1/3 of the way, and then again flatten, and then fold the other 1/3 all the way back. And then now if I open all of my folds, I have created a hexagon. Now the goal is here to fit as many circles or hexagons onto this 8.5 by 11 sheet of paper without any of the cells going off the border. It has to fit perfectly within this border, and all of our shapes are going to be either hexagons or circles. We're not mixing, and you have to keep them regular as much as possible. We're not going to fold them, we're not going to squeeze them, we're going to keep them regular shaped. Now go ahead and choose whether you're going to pick circles or hexagons. Go ahead and make the shapes, and once you have made them, then you're going to use a paper clip to connect them like so. So this would be 2 hexagons. And if I had 2 circles, this is what 2 circles would look like. Go ahead, let's get started. Now that I have made all of my circles, I've made more than I may need. I'm going to put my yellow paper right under, and I'm going to start connecting my circles using paper clips. Okay, let's see how many cells I was able to connect onto here. I was able to get 3 on the first row, 3 on each row. Let's connect them a little bit tighter and see. I was able to get 4 on this row without any overlapping, off the paper. 4 on this row, but what happens? These two look good, but these two look like they are overlapping. They're not onto the sheet, so these two don't count. So let's see how many circles I was able to get. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 circles were able to fit onto my sheet perfectly. Remember again, these two don't count because they are off the sheet. I'm going to put this off to the side, and I'm going to do the same thing now with hexagons. Now I have made all of my hexagons. I'm going to connect them using a paper clip like I did with my circles, and I'm going to see how many I'm able to fit onto this yellow piece of paper without having any of it overlap off of the paper. Now let's look at my cell with hexagons. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Does it look like anything is overlapping? Well, not only is it not overlapping, but look at all this extra space that I have. Now we just used an 8.5 by 11 sheet, but in fact the cells are much, much bigger, so I would have been able to fit many, many more hexagons. And in fact, let's see if I can scoot this up a little bit. I might be able to squeeze a little one. Not really, but there's a lot of room left here, a lot left here, and here and here. So the hexagon gave me 12, but the circle only gave me 10. Let's see why that is. Let's look at the circle. And let's look at the hexagon. By looking at them, what are some differences that you may notice? Now that you've looked at them, are you able to see why we're able to fit more hexagons than circles? I'm going to take these two off because these two are really not part of my configuration. I was only able to get 10 circles and 12 hexagons. Let's look at the circles. Does this look like it was efficient? Does this look like there was no waste of space? What about this one? Does this look like there was efficient and no waste of space? We have corners of space that we could add more, but I'm following the rules. My cell cannot fall off of the paper. But what's happening here? What what's in here? What's all of that? And that, and here. Well, the circles don't connect edge to edge because circles don't have any edges. So there's all this wasted space that the bees can't use. They can't put their honey there, they can't live there. But let's look at the hexagons. Hexagons do have edges. There's no wasted space in between. It is all cell. There is no wasted space. Now here is a real jar of honey that has the honeycomb intact and it's still. And let's look up close. What do you notice? Look at the shape. It's a hexagon. See it at this angle a little bit better. Now, just to review what we did today and the purpose of today's lab, we were talking about bees and their honeycomb structures. And we were trying to figure out, why is their honeycomb structure the way it is? Their honeycomb structures are in fact hexagons. Now, how do they know that hexagons are the most efficient, that they will store the most amount of honey without wasting any space? Our lab demonstrated that onto this sheet, I was able to get 12 hexagons. And on this sheet, I was only able to get 10 circles. Now, bees are very, very sophisticated and very advanced, and they actually communicate with one another so that they are all on the same page. They all know that they're building hexagons. Would it make sense if one made a hexagon and one made a circle and one made a square? That would be a big mess, right? Now, after you have tried this, you can try hexagons and circles. You can take it a step further. What you can do then is see inside of each cell, which cell holds more. What you can put in here are maybe pasta shells, Legos, things that are harder and not soft materials. We can't really pour honey in there because that would be really hard to measure. So you don't want to try any liquid or any materials that would be difficult or messy. But in the past we have tried large rigatoni shells, and those work really well, to see how many fit in each one of these cells. And then you can calculate which honeycomb structure will hold the most honey. Which one do you think it is? Now remember, after you've done the activity, make sure to complete your worksheet, and there is another short 10 video attached to this YouTube video. Make sure you watch that as well. Now, just to make a little correction to what I had said earlier, I had told you that 2 of these cells are falling off of the border, so we would have to take 2 off. But in fact, I would be able to fit one of these if I change the position. So to be fair, the circles actually do fit 11 circles without falling off. Well, let's adjust it. Yeah. So the circles fit 11 and the hexagons fit 12.